Usually when we look at like a broken machine or a failed project or even just a ruined recipe, there's this comforting expectation of a clear binary.
Right. Yeah. It either works or it doesn't.
Exactly. Like
Yeah.
if you drop your phone in the ocean, the screen goes black, it refuses to turn on, you just know it's dead, it's final. And we rely on those clear endings to tell us, when it's time to just pack up and move on.
I mean, we really crave that finality because it frees us from obligation.
Oh, totally.
The moment something is visibly categorized as completely finished, we just no longer have to spend any mental energy or resources trying to fix it. We can just wipe the slate clean.
Well, welcome to today's deep dive. We are so glad you're joining us because today's mission is to examine a remarkably insightful, albeit very brief, gardening journal entry that takes that entire concept of a clean slate and just turns it completely upside down.
It really does.
It's titled Notes on Gardening Part 986, How the Pagoda Plant Self-Propagated. And just for the record, the scientific name for that plant is clerodendrum-paniculatum. This entry was written by an author named Ang, and it was published on August 14, 2026.
And it's a really short entry. It's just a few paragraphs long. But the amount of biological drama and, strategic patience packed into it is honestly astounding.
It's so dense.
Yeah, the text fundamentally challenges how we perceive success, failure, and that really messy gray area in between the two.
Okay, let's unpack this, because we essentially have a mystery on our hands involving what is basically a pot of dirt that, by all conventional logic, should have been thrown straight in the trash.
Absolutely.
The ultimate gardening irony we find in this source is that sometimes doing absolutely nothing and completely ignoring a supposedly dead plant is actually the most successful gardening strategy you could possibly employ.
Yeah, the story begins with what looks like just a complete and utter failure, which, it sets this fascinating psychological baseline for the gardener.
Right, so let's look at the surface level situation to understand Ang's initial mindset before we start digging into the actual science of what was happening below ground.
Good idea.
So, according to the journal, Ang purchased this pagoda plant during the Chinese New Year season. And, during a festive season like that, you are generally buying a plant because it looks vibrant, right?
Exactly. It's celebratory.
Yeah, it's full of life. And it's meant to be a focal point in your home or out on your patio.
You're buying it for the immediate visual impact. The foliage, the structure of the main stem, the presence of the organism.
Right.
You're bringing it into your space to perform a visual function right in that exact moment.
But shortly after bringing it home, the text notes that the main stem and the foliage just completely wilted.
Just gave up.
Yeah. The plant appeared to have not survived at all. The festive display was totally gone, leaving what I can only imagine looked like a barren, crispy stick just stuck in a pot of soil.
And that visual feedback is devastating for any plant owner. The organism is offering zero signs of life.
None.
The stem is withered, the leaves have dropped or shriveled up. The entire aesthetic value you paid for has vanished entirely.
Which leads to what I think is, honestly, the most crucial decision in this entire narrative. Despite the fact that this plant looked totally dead, Ang made the choice to keep the seemingly dead plant and its pot around.
Yeah, that's the crazy part.
I want to pause here because this behavior is just so counterintuitive. Going back to that smartphone analogy, it's like having a phone with a totally shattered black screen that won't charge.
Right.
You know it's broken, but you just leave it sitting on your kitchen counter for weeks anyway, maybe hoping the internal hard drive is still perfectly intact. Like, why would a gardener keep a pot of dead dirt taking up space instead of just tossing it out?
Well, this raises an important question about our conditioning. We are incredibly primed to react to surface appearances.
Oh, for sure.
When we see a dead main stem, our immediate instinct is to declare total failure, assume we did something wrong, and just throw away the evidence to alleviate that minor guilt.
Out of sight, out of mind.
Exactly. But by choosing not to act, by resisting that urge to discard the broken thing, Ang left room for a possibility that wasn't immediately visible to the human eye.
My first thought reading that was, maybe Ang was just procrastinating.
We've all been there.
Right. We've all left the dead house plant in the corner because we just didn't want to deal with the mess of emptying the pot. But whether it was procrastination or intentional observation, that delay is a profound suspension of judgment.
It really highlights how incredibly surface level our relationship with plants tends to be. We generally only interact with the parts of the plant that exist above the soil.
Yeah, the pretty parts.
Right. We judge the health of the entire organism based entirely on the leaves and the stem. We completely forget that half of the plant, and often the most complex and vital half, exists in a totally different environment that we can't even see.
But Eng's choice to keep the pot wasn't just a lucky break, right? It was actually perfectly aligned with what was happening in the dark beneath the soil. As Eng notes in the journal, keeping the pot around turned out to be a great decision because the plant was not actually dead. The underground root system remained completely alive.
The author notes a specific biological reality here. The root system survived because it was, and I'm quoting the journal directly here, rich in stored carbohydrates.
Okay, wait. I need to stop and figure out the basic biology here because my high school science understanding is hitting a serious wall.
Sure, lay to me.
If the foliage is completely gone, like if the leaves have wilted and fallen off and the main stem is completely dead, how does a plant actually survive? I thought a plant was basically a biological solar panel.
That's a good way to look at it, yeah.
Doesn't it absolutely need leaves to photosynthesize and create energy? How can a root system just sit there, alive, in a pot of dark dirt with no solar panels to feed it?
What's fascinating here is that we tend to think of roots merely as straws.
Like just sucking up water.
Exactly. We imagine their only job is to suck up water and minerals from the soil and send them up the elevator to the leaves. But roots are also the plant's long-term storage vaults.
Oh, interesting.
When the pagoda plant was healthy, back when it had all those vibrant leaves before the wilting event, it was photosynthesizing rapidly. It was manufacturing far more food, more carbohydrates, than it actually needed for its daily metabolic survival.
So instead of living paycheck to paycheck and burning all that energy, it was building a massive savings account.
Exactly. It was actively pumping those excess carbohydrates down into the root system and locking them away.
Wow.
The root system is essentially a subterranean bunker packed with emergency rations. So when the above-ground catastrophe happened, when the main stem failed and the leaves died, the roots didn't immediately starve.
They just switched over to battery power.
Bingo. Even without a single leaf to gather new energy from the sun, the root system had enough stored fuel to sustain its own living tissues entirely in the dark.
So the surface of the plant wasn't the whole machine at all. It was just the energy-gathering attachment.
Yeah, that's a great analogy.
And when the attachment broke, the battery pack underground was still fully charged.
You know, if you're listening to this and you've ever thrown away a crispy, wilted houseplant, you are probably feeling a bit guilty right now.
I know I am.
You're realizing you might have literally thrown a living, fully charged biological battery straight into the garbage.
Which is exactly why Eng's restraint was the defining factor. The plant had the resources to survive, but it needed the gardener to simply provide the time.
Right. But obviously, a plant doesn't want to just stay as a dormant root system forever. It wants to get back above ground, reach the sun, and reproduce.
Of course.
So we have this living, carbohydrate-rich battery sitting underground. How did the plant use that stored energy to physically resurrect itself?
Well, this is where the specific biology of the pagoda plant comes into play. Eng notes in the journal that the plant propagated through something called root suckers. Right, the journal also refers to them as underground runners.
Yes. So instead of trying to push new growth out of the dead main stem, the plant utilized its lateral root network.
And those are the roots that spread out sideways.
Exactly, spreading outwards horizontally beneath the soil. It used that stored carbohydrate energy to push up entirely new, vigorous sprouts from those lateral lines, completely bypassing the original failed stem.
Here's where it gets really interesting, though. Because it's not just the fact that the plant eventually grew back. It is the specific timing of the comeback.
Yes, the timing is crucial.
Eng writes, and I am quoting the journal directly here, "From what I've read, it's rather common for the pagoda plant to send up root suckers right after the main stem or foliage has wilted." Notice that phrase, right after.
That chronological detail unlocks the entire evolutionary strategy of the organism.
It completely blew my mind. Because it implies the wilting wasn't just a slow, sad death from bad conditions. The wilting was a trigger. It makes me think of an emergency eject seat in a fighter jet. You know, the pilot doesn't just sit there as the plane goes down. The system detects catastrophic failure. The pilot pulls the lever, the canopy blows off, and they are launched to safety.
That's a really good visual.
The wilting of the top was the lever being pulled.
That analogy captures the mechanism perfectly. We initially looked at the wilting of the main stem as a failure. But from the perspective of the plant's overall survival strategy, sacrificing that failing main stem is a highly calculated move.
Wait, are you saying the plant intentionally lets the main stem die?
Think about the resource allocation. If the main stem is damaged or struggling, maybe due to the shock of being moved from a greenhouse to a retail store and then to Aang's home during Chinese New Year, trying to keep that massive struggling structure alive might drain the entire root system's battery.
It's just a giant drain on resources.
Exactly. It's highly inefficient. So the plant cuts its losses, it allows the top to die off, which instantly stops that massive outward flow of energy.
But how does a root, sitting in the dark, actually know that the stem above it is dead? Like, does it feel a lack of water pressure? How's the alarm bell actually rung?
It relies on chemical signaling. In many plants, the growing tip of the main stem produces specific hormones that travel down to the roots.
Right.
And one of the primary functions of those hormones is actually to suppress the lateral roots from sending up their own shoots. It's a way for the plant to maintain a single dominant main trunk.
Oh, wow. So the main stem is actively telling the rest of the root system, stay down, I am in charge, send all your resources to me.
That's exactly it. So the sudden absence of the main stem means those suppressing hormones completely stop flowing.
The silence is the trigger.
Yes. That sudden chemical vacuum is the alarm bell. The lateral root network registers the silence. The chemical signal essentially changes to the primary structure is gone, the suppression is lifted, release the reserves.
That is so cool.
And then the lateral roots aggressively redirect the stored carbohydrate energy into creating an entirely new generation of vigorous sprouts.
So the death of the original plant was literally the necessary condition for it to multiply. The silence of the main stem triggered the explosion of new life. It didn't just survive the shock. It came back as a whole network of new sprouts. It turned one struggling singular plant into several vigorous, independent ones.
The biological failsafe worked flawlessly. But, we can't forget the context here.
What do you mean?
This brilliant autonomous survival mechanism is happening inside a confined artificial environment. The plant is trapped in a pot under the care of a human.
Ah, right. So the plant has successfully executed this underground failsafe. But at some point, the biology needs the gardener to step back in.
Exactly.
We have these vigorous new sprouts coming up from the dirt. So what is Aang's next move? According to the journal, Aang writes, "While I'm still keeping the plants as they are for now, it's probably the right time to transplant the sprouts into new tots."
The restraint is still present, keeping the plants as they are for now.
Yeah, and so what does this all mean? Because if these new sprouts are described by the author as vigorous, my immediate instinct would be to dig them up, give them their own pots immediately so they have room to grow, and just celebrate this success.
That's what most people would do, yeah.
Why is Aang still waiting to transplant them? Are they actually more fragile than they look above ground?
If we connect this to the bigger picture, they are incredibly fragile because they aren't truly independent yet.
Okay.
Think of the lateral root connecting the new sprout to the mother plant as an umbilical cord. Or perhaps the mother plant's root system is like an angel investor funding a new startup.
I love that.
The sprout looks vigorous above ground, but it is entirely dependent on the massive established root network of the mother plant to draw up water and supply those carbohydrates.
So if I were to just enthusiastically yank that new sprout out of the dirt right now?
You would sever the umbilical cord before the sprout has developed enough of its own microscopic root hairs to gather nutrients independently. The shock would likely kill it. Waiting for the right time ensures the sprouts have matured enough below the soil to actually survive the trauma of transplantation.
And when that right time comes, Aang mentions a very specific detail about the environment these new sprouts are going to go into. Aang plans to use a sandy potting mix harvested from outdoors.
Yes, that's a key detail.
If these sprouts are so vigorous and ready to go, couldn't they just go into whatever generic potting soil is lying around the garage? Why go out of the way for sand?
You really have to consider the extreme vulnerability of a newly severed root sucker. When Aang finally cuts that connection, the sprout is completely on its own with a tiny, immature root system. A sandy potting mix is fundamentally about structural drainage.
Because you put a tiny, immature root system into heavy, dense soil, it just drowns.
It suffocates, yeah. Roots need moisture, but they are living tissues that need to breathe. They require oxygen.
Right.
Heavy, dense, or waterlogged soil fills all the microscopic air pockets in the pot. The plant essentially asphyxiates, which quickly leads to root rot.
So the sand acts like structural scaffolding. It holds the plant upright, but ensures water rushes right through the pot, leaving crucial pockets of air behind in the gaps.
Exactly. That aeration is the difference between life and death for a delicate transplant. Furthermore, by choosing to harvest this mix from outdoors, Ang might be intentionally introducing a rich microcosm of beneficial soil bacteria and fungi.
Oh, like a probiotic for the soil.
Precisely. Those outdoor microbes form symbiotic relationships with young roots, helping these independent new suckers establish themselves and extract nutrients in their new individual pots. It's a highly thoughtful, measured approach to ushering in the next generation.
It really is a complete, epic narrative arc contained in just 3 short paragraphs of a gardening journal.
It really is.
You have the initial excitement of the purchase, the apparent tragedy of the wilting, the hidden mechanical brilliance of the chemical triggers, and finally, the careful, patient stewardship of the new life.
The entire sequence of events, the actual survival of the organism, hinged entirely on the human decision to simply wait and observe, rather than immediately react to a surface-level failure.
So if you are listening to this right now, whether you're actively trying to figure out how to care for a clerodendrum-paniculatum, or you're looking for insights into botanical resilience, or honestly, if you're just searching for a metaphor for your own complex projects, this short entry on the pagoda plant is an absolute masterclass in patience.
It really forces a complete reevaluation of how we measure progress and vitality.
Definitely.
We are so incredibly focused on the visible foliage in our lives, the immediate results, the flashy metrics, the things we can point to. But real resilience is frequently built in the dark, completely out of sight.
What looks like a complete, devastating ending on the surface might just be a necessary period of storing energy below ground. It's a powerful reminder that failure might just be the quiet, invisible phase of a much larger, more successful process.
Yeah, the organism isn't dead. The battery is just utilizing its reserves while it prepares the next move.
As we wrap up today's deep dive into Ang's journal, we want to leave you with a final, lingering question to ponder on your own. It builds directly on the biology we've discussed today, but stretches a bit further into how we navigate the challenges in our own lives.
It's about taking the logic of the lateral root network and applying it to human experience.
Think about this. If the pagoda plant uses the literal death of its main stem, the sudden catastrophic loss of its central focus, as the very chemical mechanism required to trigger multiplication, could it be that a single catastrophic failure is sometimes biologically or even psychologically necessary for us? Is it possible that the painful loss of our primary central focus is exactly the trigger we need to lift our own internal suppression, forcing us to expand our hidden roots and grow in multiple new directions at once?
The idea that the breakdown of the singular main thing is the exact prerequisite for the many new things to finally surface. It's a perspective-shifting way to view any setback.
Something to keep in mind the next time you are staring at a shattered screen, a failed project, or even just a pot of barren dirt. Thank you so much for joining us on this deep dive. We loved unpacking this mystery with you, and we will catch you on the next one.